All right, today we're going to talk a little bit about logarithms. Now, a lot of people ask, well, why do we even need logarithms? Okay, well, in math, everything that we're able to do this with, we really like it to have an undo button. Okay, like how do we reverse this? So, early on in math, we came up with addition, and then what was the next thing we came up with? Subtraction. So we could undo that. We have multiplication. Well, how do we undo that? Well, it's division. Okay, we have squaring and we have square roots. Okay, every operation that we have, we try to come up with an inverse if it's possible. Okay, and remember, inverses are just reversing a function. So that's what logarithms do for exponential functions. So let's say we have some exponential function where I have b to the x equals y. Okay, now in a lot of situations, if I have b and x, that's easy. I can find y. And even if I have x and y, I can find b. But a lot of times there are situations where I want to know the exponent, okay? I want to unexponentiate this guy. So we define it like this, okay? This is equivalent to a logarithm with the same base as we had over here. So my base is b, so that's also going to be the base of my logarithm. So when I talk about the base of my logarithm, when I talk about the base of my exponential, they're the same base, okay? But the inside of a logarithm holds the result if I exponentiate this, if I do b to a certain power. Now, what power is it? Well, that's what I'm trying to find with my logarithm. So let's bring this back. So this logarithm has the same base as this, but the result of my exponentiation goes inside, okay, the answer part of this. And my exponent is what I'm solving for. Now, later on, it's going to be really important to understand that my logarithm basically represents an exponent. I'm going to say that one more time. This logarithm represents an exponent, okay? Because later on, when I start doing these weird things with logarithms, it makes a lot more sense if you realize, oh, that's just an exponent. So it does the things that exponents do, okay? So this process right here where I turn an exponential into a logarithm, or I turn a logarithm into an exponential, that's going to be really important in this section. There's going to be a lot of exponential functions where you get stuck and you go, what can I do? Well, you can turn it into a logarithm. And there's going to be other situations where we have logarithms that you don't know what to do with, but all you have to do is turn them into an exponential. So that's the first thing that we're going to practice real quick. All right. So let's say I have 2 to the third equals 8. Well, let's rewrite this as a logarithmic expression. So it's going to be log base what? Base 2. Okay, that's my base. And then my result over here, that's going to go inside the logarithm. This is the result of my exponentiation. And this is my exponent. So log base 2 of 8 is 3. Now let's go the other way. Let's say I have log 3 1/9 equals -2. Okay, how would I write this as an exponential? Well, my base is 3. My exponent is -2. And my result would be 1/9. Now, one more thing that we need to talk about logarithms. So usually we will indicate what our base is. There are 2 exceptions. So our 2 exceptions, sometimes you will have something that looks like this. And sometimes you'll have something that looks like this. This is called common log. And this is called a natural log. Okay. Now, common log, if you don't see anything here, this is equivalent to log base 10. And this is equivalent to log base E. Okay, that weird number we talked about before, that 2.71, blah, blah, blah. So if you see these on your assignments, you'll know, oh, he means log base 10. Oh, he means log base E. I will say that natural logs are probably the most important logarithms. When you get into calculus, you're going to wish that every single log was a natural log. These guys are so easy to deal with in calculus, okay? With that in mind, I also want to say that this log, this common log, where if I don't write a base, it's base 10, that's not universal. You will stumble across some textbooks where this is actually base E, okay? So it's very careful to make sure you understand what the author means when they don't have one there. Sometimes in computer science textbooks, this will actually be base 2, okay, because that's what they most commonly use there. But in our class, if you see no base, it's 10. If it's natural log, that's base E. So, for example, let's say that you see natural log of 7 equals x. Well, how could I rewrite this as an exponential? Well, what's my base? My base is E. My exponent is x. And my result is 7. Okay, what if I see 10 to the 5th equals 100,000? How could I rewrite that as a logarithm? Well, that's going to be a log of base 10. So I don't actually need to write my base here. 10,000 equals 5. Okay, so first skill you need to know about logarithms is how to convert back and forth between a logarithm and an exponential.